A lot of folks said to us, hey, I love your data drive standards. I love that I have something that tells me, okay, just based on what I'm seeing at the machine, what's a really good definition of performance? But now how does that compare to what I actually have estimated inside a ProShop, inside of my ERP system? I want to see what my estimates were to know whether my job is on track or not, to be able to pull that off. So just like on the cooking shows, I have one that we've done that on. On this one, we actually have a target that's showing here. So, 9 minutes and 30 seconds, that's the target that was actually pulled out of the ProShop instance behind the scenes to say, what is it that you plan on running? So Datanomics thinks you could actually run this part in 8 minutes and 3 seconds if you did a great job, but your estimate is 9 minutes and 30 seconds. And so you're actually going to be compared when that estimate is linked in through the ProShop integration. You're going to be compared to that 9 minutes and 30 seconds when it comes to your variance, your percentages, and ultimately your score that tells you, whether or not you're doing a good job when you're running this particular component. And
so I have a question then. So does the letter score compare then to the cycle target or the target from ProShop?
In this case, the ProShop target. Yep. So that's going to compare against the 930. Of course, whether you're 89% off or 60% off is
right.
splitting hairs, right?
Yeah.
Yeah, that's comparing to the target that comes out of ProShop.
And then just to make sure our verbiage is clear for those people on the call that are ProShop customers, that is pulling from the part level target, not the estimate target, right?
Correct.
And for those that are not familiar with ProShop, we have an estimating module where you first, generally, if you're using it, put what your estimated cycle times are or minutes per part. And that copies right over to the part record when you win a job and you make it for the first time. And then the expectation over time is as you optimize your G code, as you make process improvements, as you do better training with people, that time will get refined over time. And we even have a way to show all the times it's changed, when it changed, and who changed it. So you can keep a track of that improvement over time. Now you said button to button. So that does include the touch time, right? In this example? Okay.
Yep.
Which would be the most variable part of it, unless it's like a bar fed lathe or something automated or a pallet machine. And in that case, do you have touch time at 0?
Yep. Yeah. So touch time would look like 0 on things like that are going to be bar fed. You can see here's a Swiss turning machine that cranks out a part every half minute.
Yes.
The touch time is fundamentally 0. Any stoppages that you might incur, whether you ran out of material, you hit alarms, those obviously will show up as touch time on the component because you didn't complete a cycle without doing that activity. But for the most part, it's going to be 0. What I popped over to here was our quote calibration workflow. And this is where basically the rubber meets the road on the data that we have from Datanomics and the data that we have from ProShop, and how this is all going to get positioned together to help us understand where we are from a margin performance standpoint and how we're doing relative to our targets. So as I scroll down, this part number 3620 that we have here running on Doosan 4, we already have a ProShop target that we've pulled on this part number, 9 minutes and 30 seconds. Datanomics thinks you can run this part in 8 minutes and 4 seconds. You typically run it in 11:58. And the associated dollar values that you see here are us applying either a shop rate or a per machine rate that says, what's the minimum price that you would need to charge per piece in order to make $115 per hour at this total cycle time that we're seeing in your real information. We then go further to say, how much do we think you could optimize this job based on our analysis of your historical cycle times? How much total dollar value have we seen just in you running these components based on the per piece prices that we see over here? And then ultimately, what does this represent to you for money on the table? So we think there's about a $30,000 margin improvement opportunity on this particular part number at roughly $6 per piece. And the way that we reflect that is we actually go through a historical analysis of all the different times that you've run this job in the past, you've run this part number in the past. And you can see we've evaluated almost 5,000 total parts in looking at this workflow. And when we think about your ProShop target and what Datanomics thinks you could achieve for a real cycle time, we break down all those historic cycle times into red, yellow, green zone. Green means you run within 10% of standard. Yellow means you're 10 to 30% away from standard. Red means you're more than 30% away from standard. So you can see 37% of the time, or 1,800 out of the 5,000 pieces that we've made here, we are more than 30% off of our standard. And that's where our software has gone through and said, hey guys, we think you can run this job 26% better based on an evaluation of the information that we have. To take it even a step further, we have preloaded a number of filters here that when you have targets supplied from ProShop, you can do specific target analysis that says, hey, what are my winners? What are my losers? What are my winners that I could be making more profit on? And what are the ones that I'm currently losing on based on the comparison to my ProShop standard, but that I could be winning on? Once you're in the position where you've automatically got these ProShop minutes, estimated minutes per part linked, here's where the magic happens. So I want to come through and say, just what are the part numbers that I run where, I'm beating my targets and I'm making even more margin than I anticipated. When I come in here and select biggest winners, you'll see my target from ProShop's 2 hours. Datanomics thinks you can run it in 1:46. You typically run it in 1:51. So I'm winning by 7.5% as compared to my standard. Great piece of information. On the flip side of that, where am I losing as compared to standard? You can see I've got some doozies in here. I'm losing by 60% as compared to standard on that job that we just linked up. A couple others that are a little bit tighter, 5%, 23% here. But if you're really focused on, okay, I'm actually trying to capture margin improvement on important part numbers to the business, it's these next two filters where all the magic happens. So winners with upside. Number one, I'm already beating standard, but I need to beat it by more. I want to get a little bit more out of this component. I'm winning by 7.5%. I actually could be winning by almost 12% if I can tighten this up. And again, based on an analysis of the cycle times, Datanomics thinks you could be running this one in about an hour in 46 minutes. So a little more opportunity there. My personal favorite is losers that could be winners, because who doesn't love a redemption story? We all want to take something that's not doing well and make it do well. And some of those part numbers that we were looking at earlier, that 3620, we lose by 25% today as compared to standard, but we actually think you could be winning by 15%. Guess which part number that you're working on, because you have this information. And really all you had to do to get there was connect us up to the machines and let our software do its magic and come up with these performance standards and actuals on its own. Go through that ProShop workflow, hook into your particular instance, let the data start to come in, and you'll get that automated analysis on exactly which part numbers you need to be focused on from a job costing and margin improvement standpoint.